Hello everyone, welcome to join us in this video. In this video, we're going to learn together about AP Computer Science AB level questions sets. In this video, it will cover the question sets between 18 to 22. First, let's start with the program description below for questions 18 to 20. A car dealer needs a program that will maintain an inventory of cars on his lot. There are three types of cars: sedans, station wagons, and SUVs. The model year, color, and price need to be recorded for each other, plus any additional features for the different types of cars. And the program must allow the dealer to do the following four things. First, the dealer can add a new car to the lot. Second, the dealer can remove a car from the lot. Third, the dealer can correct any data that's been entered before. And the fourth, the dealer can display information for any car. Now let's see question 18. The programmer decides to have these classes: car, inventory, sedan, SUV, and station wagon. Which statement is true about the relationships between these classes and their attributes? Okay, let's see. There are three choices, and let's verify the correctness of it. 1. There are no inheritance relationship between these classes. We know that this is untrue. Why is that? First, we know that sedan is one kind of car, SUV is another kind of car, and the station wagon is another kind of car. So which means that between car and a sedan, between car and a SUV, between car and a station wagon, there is inheritance relationship. So we don't have to consider any choices which contain 1. 2. The inventory class has a list of car objects, which makes sense because for every dealer, he or she needs to maintain an inventory which stores all the cars that he or she has right now to be sold. So, which means that the inventory class needs to have a list of car objects. And option 3, the sedan, station wagon, and SUV classes are independent of each other, which is also true. Why is that? Because they are specialized for different purpose and target for different audience. So, which means that although they belong to the inheritance from the same class car, they should be independent of each other just due to their design. Let's take question 18. Okay, what will be the best choice? We know that choice 1 is incorrect. Choice 2 and 3 are correct. So we have to choose E, 2, and 3 only. Now let's read question 19. Suppose that the programmer decides to have a car class and an inventory class. The inventory class will maintain a list of all the cars on the lot. Here are some of the methods in the program. That is, okay, at least 6 different methods. The first method is add cars, which trying to add cars to the lot. The second one is remove car, which try to remove a car from the lot. And the third one is display car, displays all the features of a given car. So you have to specify the car for when you're trying to call the display car. The fourth method is set color. That means you set the color of a car to a given color and may be used to correct data because sometimes we might have to recolor a car. Now the fifth method is about a get price, which returns the price of a car, apparently. And the sixth one is for display all cars, which means it's used for dealers to display the features for every car on the lot. That means maybe there'll be some inheritance calling between display all cars and display car. This is just our first impression. Now in each of the following, a class and a method are given, which is the least suitable choice of class to be responsible for the given method. Which means that it does not make sense if that choice makes you feel like that. Let's see. Choice A is about a car and set color, which means that the car class needs to have method set color. It's true because when we discuss about a set color, we know that we want to set the color of a car to a given color. So which means that once we pass by maybe some class called color class to the class of car, the instance of such class car can set color by itself. Now choice B is about a car remove car. Okay, this one looks very weird because we cannot ask a car to remove itself. And that's our answer. Let's check the rest of the choices. Choice C is that about a car get price. We can locate the price by accessing the object of car, so it makes sense. And choice D is about a car display car. From our previous description, about what's the function of this display car method, actually it displays all the features of a given car. So which means that once we decided the cars, and if we call the display car, then we can list it all the feature. So choice D makes sense. Choice E is about inventory and display all cars. It also makes sense, right? Because inventory is the only class that may contain more than one cars. And of course, from the dealer's point of view, if he wants to display all cars and display features of every car on the lot, he has to do that. And the best way to implement such a method is inside of the inventory class. Okay, now we know the answer is B. Okay, let's see question 20. Suppose a car is a superclass and a sedan, station wagon, SUV are subclasses of car. Which of the following is the most likely method of the car class to be overridden by at least one of the subclasses, like sedan, station wagon, or SUV? Okay, let's see. There are 5 different choices. Right now, we know that since sedan, station wagon, and SUV, they are different kind of classes specialized for specialized purpose, audience targets, and also functionalities, features. So that means, what's the possible most likely method that will be overridden? It must be about how to compare of their full functional features. Because for any two cars, even if they belong to different types, they might still have the same color. They might occupy similar models. They might still manufactured from the same year, and also they might have been set up for the same price. But all in all, if you want to check every detail of these cars, they might be different. So once we check choice A, get color, choice B, get model, choice D, set price, and choice E, get year, we can find that all these 4 choices actually cannot distinguish the special feature of that car to tell the difference. So probably we don't have to override that part. But for display car, we believe that for every different types of cars, there might be a lot of different types, different features, different functions, different specialties. So which means that this could be the most likely method that will be overridden by at least one of the subclasses of these 3 different types of cars. Okay, so the choice is C. Question 21. What is the result of running this code segment? Okay. There are 5 lines of this code segment. The first line is a map. Map stream dwarf equals to new hash map stream, which means that it's trying to use a hash map with keys of type stream and also object of type streams. And after we initialize this hash maps, we use 3 puts and use 1 get. So the put means we're trying to put everything inside of the hash map according to its keys and also its content. So first, for this dwarfs put sneezy sick dwarf. This is on the second line. The third line, dwarfs that put happy merry dwarf. The fourth line, dwarfs put grumpy irritable dwarf. And the fifth line is eventually trying to get something after inserted or put everything inside of the hash map. Stream s equals to dwarf s that get of dopey. So the key words for this getter is about dopey. So that means we ask this hash map called dwarfs to locate the order possible keywords. Once if it gets the data corresponding to keyword dopey, it will retrieve it. But for the syntactical point of view or the grammars that we have learned about how to represent it in hashmap, how to use its putter and getter, all of these 5 lines make sense. So there will be no compiling error. Okay, let's see what is the result of running this code segment. Okay, choice A, no such element exception will be thrown. B, an illegal state exception will be thrown. C, a class cased exception will be thrown. Yeah, at least right now we know that choice C will be eliminated because we're trying to access everything by using the formal formula. So we use the .get for input one stream. So there's no class cast problem because we want to use keyword which of type stream, and we do put a stream of this get method. So we don't have to consider choice C. Choice D, the code will run without error and the S will have the value dopey, which is apparently not right because dopey is the keywords. But if we want to get to the stream, it should be the corresponding content related to these keywords. But unfortunately, since there's no record of keywords dopey that has been put from the line 2, line 3, and line 4, so the choice E will be the correct answer. That is, the code will run without error and S will have the value null. Why it runs without error? Because we have checked it before. We know that there will be no compiler error. How about the choice A and B? Is there any problem for that? No such element exception. Because it is a hash map, so there will be no such element exception. From the implementations of a hash map, it could possibly be that we want to access something that has not been inserted into the hash map. And also in an illegal state exception will be thrown. This is the choice B. But the hash map is fully maturely implemented classes that has been the package provided by the Java. So we should not expect some error like illegal state exception. That might happen. Okay, so the correct choice is E. Let's see question 22. Assume that array list is initialized with some type elements. Also assume the existence of the following method. Post condition is that return a hash set that contains all the elements of array list some type list, and we let public hash type some type of a copy list to hash set with input parameter array list of type some type called list. Now consider the following code segment. Again, this is about hash set. Okay, we use hash set belongs to some type S. We do that by calling copy list to hash set A. We next by following two lines to print out everything. Okay, now we know that A is the original hash set, and S is another hash set that has been copied. The original is A is an array list, and S is a hash set. And we know that if we want to combine elements from an array list to hash set, there could be some possibilities. So these two lines of printout actually trying to test it whether will be the difference after we copy the list to a hash set. It's trying to print out the cardinality, that is the number of elements instead of the original array list, and also the number of elements in the new hash set after copying. Suppose that the output produced by this code segment is that the number of elements in array list is 10 and also the number of elements in hash set is 6. So which is a valid conclusion? Actually, we probably can be easily trying to guess by that because there's no restriction about the repetition of elements inside of an array list. So there could be some way that one element appears twice instead of array list, but after it has been copied to the hash set, the repetition will be ignored. So that's why the hash set contains less elements than the original array list. Suppose both structures are well implemented except the difference about the content. So let's compare the choice, these 5 different choices. A, list A contains 10 distinct, i.e. different elements, and the set S contains 6 distinct elements. If that is true, then how could possibly that if we want to do the copy list to hash set, there are 4 distinct elements that has been ignored? This does not make any sense. So choice A is not a valid conclusion. Choice B, there is at least one element in list A that occurs more than once. Okay, this makes sense. Let's check the incorrectness for the following 3 choices. Choice C states that list A contains 4 more distinct elements than set S. That is not true because we know that a hash set will always contain distinct elements. But if array list A contains 4 more, then all of them will be copied directly to S. Choice D is that there are at least 4 elements in list A that occur more than once. It could be just one element that occurs more than once. What I mean is it could be that there are 5 in the first array list, and the repetitions is the redundant 4 5s. So D is incorrect. And also E, there is one element in list A that occurs 5 times, but it could be choice D. So I mean the choice D and the choice E, they just contradict each other, and they are both meet the possibility of the cases, but they're not the only choice. So the best choice is B. Okay. If you're interested in joining our class, please go to our website, which is called lamathtutor.weboy.com. And thanks for listening. Hopefully we will see you soon. Bye.